The next speaker is Rein Zhang, a software engineer at Google specializing in machine learning, computer vision, and natural language processing algorithm development and applications. Her session is titled Improving YouTube Recommender Systems for Big Screen. She will explore the complexities of YouTube massive recommender system which combine numerous machine learning and heuristic models to serve billions of users. She will focus on three major challenges: tailoring recommendations for different platforms, prioritizing system investments for optimal performance, and balancing success measurability against cost. Rein, please, welcome to the stage.
Hi, everyone. I'm a software engineer working on big screen, improving recommendation systems for big screen users. So these are the contacts for whoever created the deck. Feel free to reach out to us if you have questions. So today's agenda, we're going to talk about what is big screen recommendation system, and how our users are different, and how YouTube recommendation system have evolved, and where we are today, and how do we optimize for big screens, and where we are heading. So what is the living room? As you can see from the name, it's something you enjoy in your living room. Where we are today, we serve on different kinds of screens. We serve on gaming console. We're serving on smart screens and streaming services. And we have rise to be one of the core competitors in streaming services. And given that YouTube has the humongous corpus, we have our different possibilities over here. So what is YouTube discovery? What we're trying to do, we're trying to grow responsibly for YT viewership on big screens. And what's our challenges? As y'all know, big screen is usually shared by multiple users, and each user has different needs, and it's very different from browsing on your cell phone screen. You need to be responsibly presenting different kinds of contents that fit onto the big screen and enjoyed and consumed by multiple users at the same time. And we also need to be considerate for our partners, like different Samsung, LG, like Google TV, these different services we're on for their different kind of non-standardized APIs. And from developer perspective, we live in a huge YouTube ecosystem. We are building on top of the humongous system. How we mitigate through the different complex systems to produce the best results for our users is a huge challenge. So where we are today, we're one of the fastest growing platforms in YouTube. So here's a bit of a demo. I don't know how I can click on it. How you can find us. This is a home screen for Google TV. Usually there's a logo for YouTube. And if I click on the logo, you can see where we are. So a bit more about how you can interact with our app. So we have different, when you load up the app, we have different surfaces for you to interact. We have the homepage where different kinds of YouTube recommendations all come together: music, live, your best recommendations, shorts, everything. You feel free to enjoy anything, find anything on homepage. There's also the destination page if you feel like to enjoy some music, news, live, movies. You have all these destination pages served for you in one app. And there's also the possibility to browse while you're watching. If you feel like you wanted something different while you're watching, there's the Watch Next that you can load up. And there's also the place for creators. Users can interact with their favorite creators, and the creators can deliver users the best content they want on the channels and entities page. And there's also search, where if you have a specific thing in your mind, you can also go to the search page. So how is living room users different? First of all, living room is a shared device. So not only shared in a way that like for example, Google TV, you have YouTube, Netflix, Paramount, everything all come together in one place. And it's also shared among you and your families. So you potentially have different users watching on the same device and have mixed up watch histories. We also need to present the contents that's best for a shared user experience. So in contents that probably doesn't fit for sharing with your kids, your family, we need to optimize for group viewing instead. So there are also multiple ways to engage with the app. So as you all know, if you're watching TV, remote is the majority of the control. And with remote, you have limited access. You can be like mobile phones. You can just swipe off things. You have to navigate in one direction or the other. But again, that comes to the challenges. You can use your phone while you're watching TV. You can cast to TV while you enjoy something different on your phone. So that creates some more opportunities there. And the other thing is that TV is casual. You can't carry it everywhere. So you expect users to not come to TV 24/7. But whenever users load up a TV, they tend to have the flavor to enjoy for a long session. So how is YouTube's recommendation system work? YouTube has a billion large corpus of videos and other formats, leveraging users' history and context. We pre-select from the billions of corpus for thousands of videos with different purposes. And then these goes through the filtering system to be more responsible, to filter out contents that are not fit for the user in certain contexts. And then certain features were extracted and to go through the ranking system to rank the videos. And then there were different kinds of business logic to transfer all these ranked videos, to group them into different shelves or collections to serve for best of TV user experience. So there are shelves for videos, there are collections for shorts, live music and gaming, etc. So in general, this is a large-scale system that works so far the best for serving billions of users at the same time. So how we evolved during the years. So in 2015, the YouTube recommendation system started with a linear model, and then went to a deep model in 2016. There is a launch for multitasking, like same recommender predicting for click-through rate, for watch time, etc. in 2019. In 2023, we've gradually been moving to bigger and bigger models. And what's the benefit of bigger models? As we have been talked about in the opening speech, bigger models produce higher, better precisions with less outliers. And bigger models have more parameters for better contextualization and generalization for predicting for different user contexts. And bigger models tend to move faster, more reliably for offline eval. Like you have large, huge offline data set. With bigger models, you can more easily retrain and retune offline instead of relying everything on user feedback online, which is more responsibly developing for big, large recommendation systems. So how do we adapt for serving such large-scale recommendation systems for living room? As the conference has been talking about, it's very important for it to be data-driven, From the data, from analyzing all of our user data, we can find different user patterns. Like TV users tend to consume long-form videos. TV users prefer higher quality video contents on TV. And they love the lean-back experience. They value their autoplay recommendations. They would like to catch up with what's going on, the creators' latest uploads. And whenever they open up the TV, they tend to have a longer session. They enjoy watching more family-friendly contents. And with data, this is how we improve our ML system. So good ML or improved ML system depends on good quality of data. By examining through data, we can find parts of the ML system that probably doesn't fit for TV recommendation systems. Then this is where we can save and optimize for these models. And with data, we can cross-examine model calibration, the feature importance for how these models work for big screen users. This is a sneak peek of what the suggestions would be like when you're watching some interviews with a gamer. Okay. Another very important aspect for working on a recommendation system for billions of users is that it's very user-driven. There are constantly being UXR studies to communicate with users to gather their feedback, to understand if our features are actually working for them, what's their pain point. And we oftentimes have surveys on the platform to understand if the users are satisfied with the features we develop. That comes to the next point. So what's so special about big screen recommendations? There are some big screen features that are required that's probably not best for mobile. So there's some ground build-ups for like living room specific use cases. For example, if it's a shared device, how do we select the contents to recommend for possibly multiple shared users? Or can we solve the problem by giving user choices of their profiles, or having them created their own their shared profile? And we also need to optimize for different interaction patterns. Like most people know, to interact on TV, you rely on a remote. A remote limits your interaction. You can either scroll right or scroll down. So we need to develop models that mimic or features that optimizes for this kind of scoring patterns or browsing patterns, because it's not as easy as mobile phones. You can skip, you can just scan through things, or like desktop, you can just click randomly anywhere to pick your favorite videos. And the other thing is that for living room users or for like big screen users, when they open up, they value their lean-back experience. So autoplay, like continuously being frictionless to continuously watching similar videos in a non-disturbed journey is very important for living room users. And then there are multiple kinds of formats of contents on YouTube. As we all know, this is the advantage of YouTube, that it is a platform for user-generated contents. So there are videos, there are live videos, there are shorts, music, movies. How do we optimize for these different formats all coming together? Like, we have developed different destinations, but we also have developed different journeys when they're coming together on homepage at the same time. And the other more important thing is that there are free contents and paid contents on TV. How do we tell our users that when there's free content and when it's paid content, and how do they want to consume these contents in a more frictionless way? It's another big topic, objective for us. And There are different kinds of support for living room-specific UIs. So these UIs, they can exist, like on Google TV, you have a destination you can click on to load up the app, but there are also some like building into the car experience in Google TV where you have generic contents recommendations on Google TV's home screen. So we also need to solve for those problems with our users. Okay, what does it look like in practice? So there are two big themes here. One is ML improvements. So ML improvements depends on finding the right feature, having the proper data representation of our users, and developing large models for better generalization to understand what is the user's context, what is their previous watches like, how do we best recommend based on their interest. And system-wide improvements, it lives on a big major YouTube recommendation systems. So it really relies on us to have a good understanding of previous efforts, previous data, and how to minimize developing niche features for users while leveraging the whole gigantic system to develop on top of the shared system. And then there's also challenges to properly configure and analyze the user feedbacks, and so we can optimize or develop upon the current system. And there's all sorts kind of headroom experiments that we can understand before we actually full swing develop some features for our users. So this is the decision model. When do we decide to improve upon existing system, and when do we decide to build a new model? So it goes back to data. First, understand if this feature is new, or is this a new set of data that we don't already have. If this is a TV-only, specific data, TV-only model, then we should build a new model. If it's just piping in some new data and we can leverage the existing system, then we should always try to improve upon the existing models. And by the first initial development, if we do see the expected improvements, then we should not build a new model. If we don't, or if it hurts the existing other platforms, then there will be decision or negotiation or trade-offs to discuss whether to build a new model or to still improve upon existing model. What is our future? So first, everyone is talking about generative AI. We want to live into the YT state of models, develop for large models, and leverage generative AI to improve the user experience as well as creator experience. And in the future, we want to give users more control, as we want to be more interactive with our users and get user feedback, more real-time feedback to the model for users' preference or users' feedback for the features, so that we can improve upon the user feedback for the models to develop upon. And one last point is that we want to leverage the living room specific signals and build and improve upon the current large YT system. So like there are features that, for example, co-viewing experience. It's very living room specific, but leveraging the co-viewing experience could also help other parts of YouTube to improve the user recommendation system for your mobile phones and desktop, etc. So I guess this is my speech. Any questions? Or early?
Let's see if there are any questions.
Yeah.
If anybody is interested to ask, or we have like About 2 minutes. Here. Yeah, just wait for the microphone. Quick. No, see, here's the microphone is coming.
Hi, thank you. So you mentioned that you worked with different input devices like phone and remote and all of that, and that just got me wondering, how do you deal with this different architecture of inputs, essentially? If you can say a word about that.
So like, if you have your phone, you're generally most likely, like in second screen, have two aspects. You can cast, while your TV can be logged out on a share or on a different profile. You can also be logged in on your TV. You can also connect to your TV. So use your phone as a remote while you can browse while you.
Sorry, I mean, I understand how the problem is made. I wonder how it's solved, how you solve it.
So it's different signals in the system. With remote, it's just generic the device type when you're recommending for the TV device type. When you have the input as the phone's casting, it's a different signal.
Any more questions? Yes, another one here. Here. Yeah, okay.
Yeah, hello. Thank you, first of all, for your speech. You mentioned about what if like people have the common account, share account, and like two users can use one account. So are you split somehow recommendations for, do you try to identify which users now is connected, or you just show like the one common batch recommendation for this account?
So if the same account is used by multiple users, we're trying to recommend for the best of experience, assuming that's still consumed by multiple users.
Sorry, microphone, please.
Yeah, so it's still one account. The watch trees are still coming together, so it's still trying to recommend based on the watch trees of multiple users and contents to be assuming to be consumed by multiple users.
So, but basically, like both users from this account will get the equal recommendations, right? Mm-hmm. Okay, thank you.
Okay, are there any other questions? Yeah, here.
Yeah, thank you for interesting presentation. Can you tell me what kind of technology do you use for data streaming? Because I guess that you need real time. Okay, I'm on your right.
Oh, sorry, say that again.
What kind of technology do you use for data streaming? Because I guess you need to provide real time recommendation.
What, for streaming?
Yeah.
Oh, so it's server-side recommendation and returns back to device for rendering.
Okay,
Okay,
I think we'll have to stop here because we have no time left. The next lecturer is waiting. Thank you. Thank you, Rein.
Thank you so much.